and this is h in the notes. So what it should say, this is page 3, should be f times g dx dy. I left out the fg. Okay. What? Yeah, because the example on page 3, the first product I carry out, at the very end I just have dx dy.
Oh, okay.
Yeah, there should be an fg sitting there. Yeah. Okay. Now, on the other hand, if you multiply them in reverse order, okay. All right. Then we're going to have sine y dy, wedge x squared dx. Pull out the functions, you get x squared sine y dy wedge dx. Okay. Now, both of these forms that you're multiplying are one forms. So this is going to be x squared sine y times minus 1 to the 1 times 1 dx wedge dy. So that's going to be minus x squared sine y dx dy. Looks like I messed that one up too.
So this.
That should be 1 times 1. Yeah, you multiply the orders together, not add them.
And that would make our final answer negative.
Yes, it will.
Okay.
Yeah. So you can write it either this way, minus x squared sine y dx dy, or positive x squared sine y dy dx. So interchanging them is going to... So in general, when you have two one forms and you multiply them, if you switch the order, it's going to negate them. Like you have here and what we have here. So... All right, so this is the first correction to page 3, and then, so also on the same page, we should have minus fg dx dy.
Someone could be racking up points.
Yeah. Okay. So this is, that's the problem. Once we get to the end of the semester, it's like, God, I'm so sick of typing these up. You just want to get them over with. All right. Okay. Now, let's see. As far as I can tell, the other ones are right, but let's do the examples anyway and make sure. All right. Alright, so now we're going to take these two, nu and omega, and multiply them. So, wedge omega, so that's going to be, you pull the functions out again, so it's going to be x, y, z squared times x squared times this product, dy dz, wedge dx. So you're going to get x, y, z squared, x cubed now, dy dz dx. But we would like to get this in the standard form. The trouble is the dx is at the end. We'd really prefer that it be at the beginning. So we're going to interchange these two. That will flip the sign. dy dx dz. Now we'll flip these two, change the sign again. dx dy dz. All right. But what if we instead multiply these two, nu and eta? So you pull out the functions. So we're going to have x, y, z squared sine y, dy, dz, wedge product with dy. Well, what's going to happen is ultimately you're going to get minus xyz squared sine y dy, dz. We have two dy's in a row, 0. Okay. So interchanging one forms flips the sign. If you get two of the same, it's 0. Those are the main things you need to know when computing wedge products. And if you have, yeah.
It will always be 0 if we have two of the same.
Yes.
Okay.
Yeah. And the other thing is, here all of these forms that we're multiplying, they have just one term. But if we have forms involving two terms, or two or more terms, then the distributive law applies. But that's the ordinary distributive law that you know. Okay. All right. So any questions about these? Yes.
I assume, I mean, I don't know if there would be a case for, but what if you had like 3 dy's, it'd still be 0, right?
Oh, what? What if you had 3 dy?
Like if you had dy, dz or something like that, you'd still get 0, right?
Oh yeah, yeah. This is the moment you get two or more
Two or
that are
more.
the same, then the whole thing's gone. Yeah, yeah, because you'd end up having it becomes 0 just because of the pair multiplied with other forms, but 0 times any form is still going to be 0, just like with anything else. All right. So that's how you multiply forms together. But now there's differentiation of forms. So it's really more like a generalization of differentiation of functions. It now has to take the these basic one forms, dx, dy, dz, into account. Okay. So Floyd's not here because he's busy playing on Facebook. Okay.
Oh, that's great.
I love them cell phones.
All right. So,
What's up on Facebook?
I wonder if he's gonna watch this lecture, then he'll see like, oh. You probably have to be careful when he
or should I say bunny head?
gets a job.
All right.
Career that is correct.
Now, differentiation. Okay. So here are the rules. There's just a few of them. And if you have just a function, so any 0 form, the letter D here indicates differentiation. So the derivative of any 0 form is going to be partial with respect to x times dx, partial with respect to y, dy, plus partial with f respect to z, dz. So you can also think of it as the gradient of f dot product with the vector of these basic one forms, dx, dy, dz. So the derivative of a 0 form is a 1 form, and so on. So derivative of any k form is a k plus 1 form.